one of the key things that you should have picked up on in your reading this week with mass movement is the amount of water is really going to impact what our material looks like as it moves down slope and really have an impact on how quickly it can move as it's coming down. So you should have touched on the types of movements in your reading, so we can have creep, fall, slides, and flows. So creep, remember, is basically this imperceptible downhill movement that we see. A fall tends to be free-falling objects. We typically think of it in terms of a rock fall. Slide, we are moving as a cohesive group kind of down the slope. And then flow, we're acting very much like a lake. So creep, we see really in evidence through trees, through telephone poles, through fence posts. I like to think of it almost as how when people get older and they get wrinkles, it happens very slowly over time. So we don't see it with our eyes. We can kind of see it, especially when we look back. And in this example here on the right, the trees have actually started to grow back towards the sun, so they get this curve. This tends to not be very dangerous because it's happening, but if you're building on it, it certainly could destabilize your foundation or your fence posts or your electrical lines. Falls, we have this free form, free falling through the air. A lot of times the rock is going to break or fracture along cracks as we see on the right. And the particular example on the right is once we get a little bit of a crack, if we get water in there, as it freezes, it expands. And so we can kind of, it's almost like loosening a tooth. So many situations of where we get water in that crack, freezing and pushing it apart will eventually lead to that fracture. In most cases where we know rock falls are going to be a problem, we'll see fences or walls typically along the side of freeways so that that's not falling into the roadway. We can also see a fall as a result of an earthquake activity. In terms of slides, we have two types, rotational and translational. So if we start with our rotational, what we see is a cohesive amount of material. So it tends to be more soil, not fractured rock. There is water content, but not a huge amount of water. So it's just kind of like soil or material. And what we see with this rotational, as you can see in both images, is that it actually curves and moves down along that curved surface. So it does rotate. It's almost like the bottom sinks out forward. And so we get a little more of this rotational where it kind of slumps and then sits in one spot. When we look at translational, we're actually moving over a surface, so a weakened surface, as again a cohesive amount of material, but it tends to be able to move a greater horizontal distance because it's moving and not slumping down and kind of giving into that gravity, but continues to move downhill. Lastly, we have flows. These are going to move very much like a liquid, tend to have a very, very high water content, almost enough where it's all water in some cases, especially when we get into mudslides. This is going to be able to move fairly quickly, and it's going to be able to move for far distance because, again, it's very fluid-like. We can really see flow be almost all water. It could be snow in an avalanche type situation, and in some cases we're going to see larger pieces of rock that will get caught up in this material. They can range in speeds all the way up to almost 200 miles an hour in the right condition, and certainly here the amount of water is going to be what is the key factor here.